Hello there. This time we are going to consider articles 112 and 113 on page 72. These two articles focus on the property of angle bisectors and the associated medial triangle of a given triangle. So let's start. The foot of the perpendicular from a vertex of a triangle upon a bisector issued from a second vertex lies on the side of a medial triangle opposite the first vertex considered. Yes, I agree with you. It's a little bit wordy, but let us try to scrutinize it so we would understand it fully, okay? So the foot of the perpendicular from a vertex of a triangle, so that's vertex is angle A, okay? Issued from the second vertex, and that's this one. Second vertex is B, and the angle bisector of that. So here's the thing. So the angle bisector, so that's the angle bisector of angle B. So lies on the medial triangle. Before we do that, let's go back to the first sentence. The foot of the perpendicular from the vertex. So the foot of the perpendicular from point A. So what that means is to construct a line from A perpendicular to this angle bisector. So let's construct that one. It's here. Oh, that's the reason why I call this point P, okay? So the foot of the perpendicular is point P. So this particular point P, it says it lies on the medial triangle of this one. So let's consider that. The medial triangle of the yellow triangle is this. So you notice that as I drag point C rather, point P lies on this side of the triangle. Oh, that's what it means. Now, if I drag it a little bit further here, oh, wait a minute. So, but this side here, P lies on the side extended, okay? So it lies on the extended side of the medial triangle, so it's still okay. However, let's consider this particular situation, okay? So the foot of the perpendicular P lies on the medial triangle, etc., etc. Oh, that's what that means. Oh, okay, so let's try to figure out what we can do with this, okay? Let's try to hide first the medial triangle. I don't need that. So what I needed was to just construct this one and name this point Q. And since I named this point Q, you will notice, people, that this triangle is congruent to this triangle. Okay? Why is that the case? This is an angle bisector. That means this is congruent to this. So let's put that one. Angle 1 is congruent to angle 2. So angle 1 is congruent to angle 2. And this is 90 degrees. Let's change that one. Let's remove this. And then let's just make it simple like that. And there we go. So this is 90 degrees, and this is also 90 degrees. In that case, and BP is congruent to itself. So let's write it here. Okay, so angle 1 is congruent to angle 2. And then angle APB is congruent to angle QPB. And BP, or segment BP, is equal to or is congruent to segment BP, and therefore triangles BAP is congruent to triangle BQP. And what will be the conclusion then? If that is the case, then what we can say is that because that is true, now we can now say that BP or AP is equal to PQ, or P is the midpoint of segment AQ. Wow, this is a very important result. So, what does that mean by saying that P is the midpoint of segment AQ? That means I will now remove this and I will remove that. What that means is this. Let us first recall the locus. Okay, so let's hide this one first, and let's hide this, and let's hide the yellow triangle. We can keep the, but let's focus on the yellow situation. Okay, now we remember, so this is any segment. AR is any segment on the triangle here. It's called a Chavian, but this is just any point here, and I actually can drag this. See that? So AR is any segment in the triangle where R is on base BC, and I made a fix, and M is the midpoint of this segment. So the locus of M as R moves is actually the mid segment of the triangle. As a matter of fact, this particular locus here, if I show you the medial triangle, coincides with that mid segment. Okay, this is the midpoint, and that's a midpoint, and therefore this is the mid segment. So that locus is indeed the mid segment. Thus, okay, let's hide this one now. Now, and let's consider the angle bisector. Thus, P will always lie on the medial or even the extension part of the medial triangle. Okay, the side of the medial triangle. That is cool. Hello there. This is a continuation of the discussion of Article 112, which is a very immediate consequence of it. Hence, we can call it a corollary. Okay, so before we do anything, let us recall one more time the theorem that was discussed in Article 112. The foot of the perpendicular from a vertex of a triangle upon a bisector issued from a second vertex lies on the side of the medial triangle opposite the first vertex considered. Again, as I have said before, it was too wordy, but we were able to understand what it is. So, the first thing that we need to do is consider the angle bisector of angle B, and that's this particular thing. I call it T sub B. And then I need to get the foot of the perpendicular, So let's construct a line perpendicular to point to the angle bisector and passing through point A. Hence, P is the foot of the perpendicular. And what we discovered last time was the fact that that this particular point P will always lie on the medial triangle, on one side of the medial triangle. Hence, you notice that P is on this side of the medial triangle. Even if I drag it here, it seems that, oh wait, P is not on the medial line, but what it means is on the extension point. So we can call, if we connect this point and this point, so we can call that the medial line. So P is still part of this particular medial triangle, but only on the extension side, okay? So P lies on the medial line. So, and right now it lies on the medial triangle, okay? So that's what it is. So the corollary, but is P the only point that lies on the medial triangle or on the side of the medial triangle? Well, the feet of the four perpendiculars dropped from a vertex of a right triangle upon four bisectors of the other two angles are collinear. What that means is, so this is just one of the internal angle bisectors. If I consider the other angle bisector, so now I have T sub B. Now I have here T sub C. Okay, now where is T sub B here? There you go. Okay, let's make the label somewhere here so that it will be, okay, there you go. So this is the angle bisector from vertex C, and this is the angle bisector from vertex B. And then if I consider the foot of the perpendicular from here to here, it will pass it through P, and therefore they will also be, the point Q will also lie on the medial line or on the side of the medial triangle, okay? But it says here that the foot of the four perpendiculars, wait a minute, these are the two angle bisectors. Do we have other angle bisectors? Yes, we do. Okay, let's consider first line BC, and this is the external bisector of it. So let me construct that. So this is the angle bisector from, this is the angle bisector from external bisector from point B. That's why I call this T prime of B. This is T of T sub B, okay? And on the other hand, this one is the angle bisector, external angle bisector from vertex C, and this is the internal angle bisector from vertex C, okay? And if I construct the fit of the perpendiculars, there you go. From point A, I constructed a line perpendicular to this external bisector. It passes through point S. From point A, I constructed P. From point A, I constructed point Q. And finally, from point A, I constructed point R, okay? Are they collinear? Let us extend this median, this line, which is part of the medial line, and that's it. And that's the medial line. And you notice, people, that points P, Q, R, and S are all collinear, and they all lie on the medial line, okay? Which is nothing but an immediate consequence of the theorem itself. That is so beautiful, okay? So let us try to hide certain things so that it will be much clearer for us now. What else do I need? I need to get rid of this. But if you notice, people, I want to mark this angle and this angle are congruent because they have been cut by this angle bisector. So let's do the line angles here. So you notice here, angle 3 is congruent to angle 4. Angle 1 is congruent to angle 2. So the internal bisector at B is angle 3 and angle 4. Oops, this has to be internal. And the other one is external. So external bisectors would be angle 1 and angle 2, and that's equal to x. And internal angle bisectors are angle 3 and angle 4, and I make that equal to y. Hence, 2x plus 2y is equal to 180, or x plus y is equal to 90. What that means is that the internal angle bisectors of the triangle will always be perpendicular to each other. Very beautiful results. So the collinearity of the fit of the perpendiculars from A, okay? And that's what Article 113 is all about, which is nothing but a corollary to Article 112. Thank you very much.